Hey friends, in this video, I will talk about how RAG works conceptually and how it is a vital component when you're building an OpenAI assistant. So by the end of this video, you will have no more confusion with RAG and you will start putting this into practice. It is one of the key concepts when you're trying to build OpenAI assistants by augmenting knowledge from your documents to your OpenAI assistant so that it answers much more concisely and much more accurately based on the information that's provided. As you know, LLM models have a foundational base knowledge. They're trained on the internet, trained on the historical data, and that is where it becomes a problem because sometimes when you're asking questions relevant to, let's say, your business or certain domains, it falls short because it doesn't have that source. Perhaps it doesn't have up-to-date data. So without that kind of data, it's unable to provide you that information. So what helps to augment their response is providing documents, PDF files, Word doc, or any documents that can help give more context to the assistant. It helps them answer the questions a lot more easily. Let's go. So we're going to be talking about RAG, Retrieval Augmented Generation. Let's say you have your document here, it's uploaded, right? It could be a PDF file, a Word doc, or a JSON file. What's happening behind the scene is OpenAI is converting it into chunks of text. So you have a document, it has a bunch of stuff on it. It's basically scraping all that text, assembling it, and then it breaks it into sections called chunks. Chunks are basically tiny versions of that document. You can specify how many chunks OpenAI should process, but just imagine tiny versions of that document as chunks. Another thing, chunks could overlap with each other. It's passages of text. Okay? Now there could be potentially 50,000 different chunks in one document. I'm just using 4 for illustrative purposes. And then it is stored into something called a vector database. And in order to store the chunks, we need to convert these chunks into numerical representations of the data. And that's how it's stored efficiently in the vector database for retrieving later. We use things like an embedding model to convert the chunks or text into vector embeddings. These are just basically numerical representation of the data. This helps to store in the vector database. Now let's say you are a user and you want to ask a company, hey, what is the return policy of your program, etc. So you have provided a query, okay? That query will be sent to the vector database and it will find relevant chunks through keyword matching or semantic search. Conceptually, it will try to understand what sections of the documents talk about return policies, and it's going to return those chunks and augment the LLM model. The assistant will now augment the foundation or base knowledge of the LLM with those relevant chunks that contain information about the return policy, and it's going to produce an output or query output. By having a RAG framework and by incorporating your own additional documents to the LLM, you're able to assist the LLM to provide more concise and accurate responses. Now, your documents have to be up to date and correct, because if you're also providing faulty documents, then garbage in equals to garbage out. So that's one of the cons of RAG systems. You have to make sure you're providing up-to-date documents that are relevant and will help augment the responses of the LLM. By applying RAG, you now solve the problem of hallucination. Sometimes the LLM can still respond inaccurately, even though you've provided your documents. There are still some techniques you can employ to ensure that your documents are correct, and you can fine-tune the LLM models so that you can provide a much more accurate response. Now, if you want to learn more about how you can apply RAG frameworks or build OpenAI assistants for your specific use case, make sure you join my school community GPT Pioneers Club, where I reveal more techniques, create OpenAI assistants with your own documents, and then also deploy that. So make sure you join the school community. And if you found value in this video, make sure you like, subscribe, and hit the notification bell every time I come online and provide value. If you want to learn how to build streaming chatbots with OpenAI assistants, watch this video right here. And if you want to see if Google Gemini can accurately guess how many goals Messi scored in the World Cup, then watch this video right here. GPT pioneers, let's go.